All right, welcome back to pre-calculus. So we're going to continue talking about partial fractions and see how far we can get with this problem here, okay? So they're getting a little trickier, that's good. Okay, so here we have 3x squared plus 2x squared plus 12x plus 4, okay? And on the bottom, that's really the part we care about, okay? We usually put a mess up here just to have something, okay, for us to work on. But on the bottom, we have a 4x squared, okay, plus a 2x squared plus 1. Oh, they're clever. Look at that. X to the fourth plus 2x squared. That looks like x squared plus 1 squared. Okay, so factoring is going to be kind of an important part of doing this section. So if you need some practice on factoring, go back and look up like factoring worksheet. Just type that into your favorite search engine and see if you can't find some good factoring problems to brush up on. I don't have a good source for you because that's what I do is I just type in factoring worksheet and then see what happens. But that's what we have. But notice this is an irreducible quadratic. So in order to set up an irreducible quadratic, we need ax plus b over x squared plus 1. But we have a repeated root, so we need two of these. So we're going to have a cx plus d, but even though it's an irreducible quadratic, we just have a repeated factor. So that's x squared plus 1 squared. Okay, and that's how you set those up. Again, that's the hardest part of doing this. These start to get a little tricky. Okay, but you just have to remember, it's like, okay, what's the shape of the thing on the bottom? So what's an irreducible quadratic? So the shape of the thing on the top is going to be a polynomial of one less. And then you're going to need as many terms as you have repeated roots here. Okay, that's pretty much what you do with this. Okay, so we're going to say this is an ax plus b. Okay, this is going to be an x squared plus 1. Put parentheses in here, and then plus, and I'll put the fraction. Okay, and that's going to be a problem too. Cx plus d, and on the bottom, we're going to have an x squared plus 1. Oops. That's fine. Cx plus d, and then do that, and now we want x squared. Hopefully I can get this in this time. Plus 1, and then we'll put in the 2 for that one. Okay, so it's important to remember, get your repeated roots to come out, okay, and then have a term for each one of these, then term with each root as it's repeating. Okay, there's some problems where you end up with like an x to the cubed, so you have an x squared, x cubed. But because there's only x on the bottom, it's just a constant on top. Because the shape of the bottom is an irreducible quadratic, the shape on the top is a factor. It's an irreducible quadratic with a repeated root, repeated term, but the shape on the top is still just an ax plus b kind of a thing. Okay, so we'll go ahead and check that one, get the green flag, and then we'll go on. Okay, so try not to be, don't let them trick you. Just take it and look at the shape of things that are on the bottom and then reflect that shape to the numerator. And if you need more terms because you've got extra repeated terms, that's okay. Okay, this does not influence what's going on here, because it says it has to be irreducible quadratic. If you multiply it out, it would be reducible. You could factor it. Okay, take this instead. Okay, so good luck with doing these, and I will see you in the next video. Thank you.